Okay, so recording has started. As I was saying, tonight's meeting and the rest of the meetings from here on out are going to be 90 minutes, but we'll still do the 10-minute break 50 minutes in. So at 10 of, remind me if I don't remember to stop and give you all a break. Anybody have any questions or problems with the first lesson, the homework that they want to bring up before we jump into this? Okay, let me share my screen. And we're going to do this the same way we did.
Can I ask a question actually about the homework? I'm sorry for jumping in at the last minute.
Oh, that's okay. Shoot.
The one about the dog years to human years, I had a little bit of a problem with. I couldn't figure out the right formula for it. Would you be able to go over that question?
Sure. Yeah. Let me jump into this lesson, and then at the end, stay on the line, and anyone else who's interested, stay on with us, and we'll go over that. And if I forget, please remind me.
No problem. Thank you.
Work for you? Okay, so we're going to do a notebook again. So please go to, last week it was mco.fyi/pi1. This one is creatively called mco.fyi/pi2. So please go ahead and navigate there. And when you get there, best thing to do is to make a copy of that notebook using the File, Save a Copy in Drive menu command that you probably have already done. And give me a thumbs up or some kind of a sign if you've gotten there. Have your own copy going. Okay. We're going to do this the same way we did last week. I think I just said that. We're going to kind of walk through this notebook, and I'll just explain concepts, and I invite you to execute the code as I do it. Now, what we're going to work on today is filling out some of the basics. Last week was like, starting from scratch with floating point numbers and integers and strings, the most basic types of data in Python. We're going to fill that out a little bit with a couple of other data types. And we're going to talk about something called Boolean operators and Boolean expressions. And when we're done tonight, you're all going to be experts on Boolean logic, which is actually not anywhere near as hard or as scary as that sounds. But it's actually really important because almost everything in computer science is built on the building blocks of Boolean functions. So it's really transcends much more than Python. It's in every programming language. It's even in the hardware of your computer that these Boolean functions exist. So it's a very good thing to know about. Let's jump right in. So I first wanted to mention...
The link doesn't work.
Your what doesn't work?
The link doesn't work.
Tell me
the link to the notebook doesn't work, Mark.
Oh, okay. Sorry about that. I forgot to build the short link. I'm going to give you the long link in the chat window. Thank you, Jordan. Okay, if you can open the chat window, you'll see a link. Go ahead and click on that. And let me make sure I have sharing enabled.
We need access to it, Mark.
Not doing so good so far. All right. Anyone with the link can view. Try again.
Yeah, it's working.
Good. Okay. Sorry about that.
It's fine.
When you get in, go ahead and make a copy using File, Save a Copy in Drive. And if something's not right, like if the screen is too small, which reminds me to do this right now, Or if you can't, what you just did, like tell me you can't get into a link, just do what you did. Unmute the audio and jump right in. And don't worry, please don't worry about interrupting me. I'd rather know that something needs to be adjusted. So is everybody in now and have their copy of the notebook?
Mark, can we make a screen a little bit bigger, just a little bit bigger?
Sure. How's that?
Perfect, thank you.
Okay. Okay, so last week we started out and we saw some data and we talked about variables, but I wanted to make a distinction, and this really is more of a terminology thing than anything else, but you'll hear these terms all the time and I wanted to make it clear what they mean. When you see in a program a value like a string, like Mark shown here, or a number, when it's like right there in the code, we call that a literal value or a constant. And it's called a constant because once you write it, that's all it is. It doesn't change. The other thing we saw was variables, and these are the names associated with some piece of data. And they're called variables because they vary, so they can change over time. Now, the underlying data, the way variables change is they just point to another piece of data. So the literals are the actual data values and the variables are the names. Variables can be simple, and those are the only ones we're looking at right now, but they can also be complex variables, which is where a variable would point to a collection of data. We haven't seen those yet. We'll get to those in a future lesson, but I just wanted to let you know that the general concept of a variable can point to just a simple thing or a very complex structure. The next type we're going to look at is called bool, B-O-O-L. And it's short for Boolean. And Boolean variables are used for indicating a truth value. In other words, if something is true or false. So they're binary type. They're binary type, meaning they take on only two values. And the two values are actually special names in Python, true and false, with a capital T and a capital F. So you actually literally write those strings, and you don't quote them. They're not strings in the sense of the string data type. They're just special names in Python, like import or print or any of those reserved words. And they are reserved words, so don't try to use those as variable names. When you evaluate a number as a Boolean, so you try to say, determine the truth value of a number, there's some special rules that 0 is false, and non-zero is true. This is sort of trivia for right now, but this will come back later in the class and you'll see where this is handy to know. And there's a similar rule with strings. The empty string is false and a non-empty string is true. The general rule, if you forget this, is that nothingness is false, is considered false by Python. So an empty string or a 0. And somethingness, which probably isn't a real word, is considered true in Python. So again, the value of that will come back later, but I just wanted you to be aware of that rule. In this code cell, you can experiment with turning different things into bools. So I should probably, if you just say bool, the notebook will tell you what it returns, but to be more formal, I should probably say print of bool. And then I'm giving that's a space. And because it looks empty, right? But because it's not the empty string, that should be true. And sure enough, Python tells me it's true. If I give it 3.14, the floating point number, it's also true. What would be false? Well, 0 would be false. 0.0, the floating point version of 0 would be false. And an empty string, double or single quoted empty string would also be false. Now, the truth or falsehood of a literal thing is not terribly interesting. It's good to know, but what's more interesting is when you have variables and you want to test the truth or falsehood of a variable. And we'll get into how that all works in a few minutes. One other type I want to tell you about is called the none type. In other languages, this is called null, and it represents, it's more nothing than 0 or empty string. It's really like an undefined value. And the typical use case for this is if you want to name a variable, but you don't know what you want to assign to it yet, maybe it's a number and you're not sure what number to start with, you can give it the value none. You can also return none from a function, and that tells the calling party that you have nothing to say or nothing to respond with. I didn't tell you what a function is yet, so I'm always running into these forward dependencies here. But I just want you to know there's a special type called none, and it has the variable, the value, a special name called none with a capital N, just like true and false. There is a function for each of these types. So if you have a type of a variable of a given type or a literal value of a given type, and you want to convert it to one of these types, you can call the function associated with that type. So we kind of already saw that when I did the bool thing a minute ago, but I'm just going to add a code block here. And let's can do this the way I was doing it before, where I was saying bool and then a literal, but let's put it in a variable just to show you that you can, anything you can do with a literal value, you can usually do with a variable. So I'm going to store something in the variable. This is the string 2020. It's not the number 2020. So for example, if I try to add a plus 1, it should give me an error, and it should say you can't add a string and an int, which it did. But let's run this, say print int of a. Okay, so that's calling these things sort of get executed from innermost to outermost. So the innermost thing here is saying, call the int function and pass it the variable a. Well, a happens to have a string, 2020. So the int function is going to say, okay, got your string. I'm going to turn it into the integer 2020. And I'm going to print that. So let's see if that works. So I did what we thought. What if I didn't call that int? What would the print look like? Let's try that. It's 2020 as well, but it should show me, actually it doesn't show me the quotes when I print it that way. One way we can force that issue is we can say, what is the type of a? Because like I want to know, is it really an int or a string? So I can call this function type and print the results from type. So the results of type A is class string. Don't worry too much about what class means. We'll learn about that later. But the important part right here is stir. It's telling you the thing you sent to type was a string. Now let's get rid of the single quotes and run that same code. And it's telling us the thing you sent to the type function is an int. And the type function just returned this string, class int, and then I printed that string out. So this is type is just a way to find something, find out what type a certain literal or variable is. Now, what if I do this? Float. Anybody want to guess what that will? I mean, the reply from this print is obvious. It will be a float, but the value, I'm sorry, the type would have said float, but the value, what it did was it turned this int into a floating point number. So nothing too mysterious about that. What if I try to convert this string to a float and print it out? Any ideas what might happen there? Value error. Could not convert string to float. Sorry, I asked the question and I didn't give you time to answer. I'll try to be more patient. I'm sure you were going to say that it's not going to be happy, and you were right. It can't convert a string to a float. It just doesn't make sense to consider mark a thing in the floating point universe or the integer universe. Any questions on that? So now you know both the type function, which is good to know about, and these conversion functions, which give you the ability to change a value from one type to another. But when do you need to do that, or why do you need to do that? Sometimes you have an expression containing mixed types, like name plus a number, age as a string times a number 365. You might have seen this in the cat food program where you ran the input function to get some input. It came in as a string, and then you were trying to do math with it, and then Python said, no, you can't do that. Sometimes you want to pass a different type than the one you're sending or the one you have in your hand. So like if you call this This is a good function to know about. It's random.randrange. And what that does is it picks a random value from the range you provide. So if I say random.randrange 11, it says that's an invalid character. But if I turn it into an int first, then it should be okay.
Why do you have to turn it into an int first? What's the difference between just writing 11 versus int 11?
I have an I there. I'll get to that in one sec. Let me just see if I can make this work. Okay, so it took a random value from 1 through 11. So why do I have to turn it into an int? It's simply because this function, and if you highlight and hover over a function, you get some help data for free. This says I have to pass it a start value, and it doesn't actually specify. If I Google this, I'll see. Actually, you can click here and view the source. And if you do that, what you're actually seeing is the Python code that implements this randrange function. So that's kind of cool to be able to do. But one of the things you'll see is here's the definition, and we haven't talked about def yet, so don't worry if you're not sure what that means. But one of the things it's doing right here is it's saying raise an error if it gets a non-integer argument 1. So the answer to why I have to pass an argument is simply because the person who implemented this function said so. They wrote the code to expect an integer, and I have to just know that. If I just pass it a string like I did, it's not going to work. And fortunately, the programmer put a check in there to say, if you pass me an integer, you can't do that, and here's why. So he or she is helping me to know what went wrong. But that's kind of why you have to do that. So that's another scenario where you'll want to do a type conversion. I just told you about the type function, so I don't need to tell you again. This is worth running. It does stores in a variable the type of all these different things, and it prints those types, and it should look exactly like what you expect according to the variables you've passed to type, or the values you've passed to type: int, float, stir, bool, and none type. And those are the 5 types we've learned so far. Okay, that's it for types for today. We're now going to talk about how you take data values and construct Boolean expressions, truth or false values from that data. So the first thing I want to tell you about is comparison operators. And we saw some operators last week, but they were arithmetic operators: multiply, divide, etc., exponentiation, and so on. These are called comparison operators because they establish a truth relationship between 2 arguments. And the result of applying these operators is one of the 2 Boolean values we talked about, true or false. The operators are probably going to feel natural to you. Equal to is a double equal sign. Not equal to is an exclamation point equal. Not is often, exclamation point is often used in computer science as a shorthand for not. Greater than is the mathematical definition of greater than, a bigger number or a more positive number. Greater than or equal to is more positive or the same. Less than is what you're probably used to with less than, and less than or equal to is the equivalent in the other direction of greater than or equal to. You can apply these things to strings, and they're similar comparisons, but when you're trying to say a string is greater than, well, actually, let's try that, and I'll see if you can get the sense for what it's doing. So I'll do first with numbers. If I do 1 equals 1, the result of that is true, the Boolean value true. If I say 1 equals 2, or 23, because I can't type, the result is false. So it seems reasonable. If I say 1 is not equal to 23, I get true, because it is true that 1 and 23 are not the same thing. 1 is not equal to 1 is false. Sometimes it takes a little while to wrap your head around these double negatives, but hopefully that makes some sense. 1 is greater than 1 is false, because 1 is the same as 1. 1 is greater than or equal to 1 is true because equal is allowed with greater than or equal to, obviously. Now let's look at strings for a second. So string name equals mark. Now this is not the variable. This is just the literal string name, and obviously name is different from mark. I shouldn't use name because it's sort of a meta concept. I should use another name. So I'll say Maya equals mark, and that's false, obviously. Mark equals mark is true. What about Maya greater than mark? Before I press enter, I want you to think about what you think should happen there. True or false? If anybody wants to unmute and jump in with a guess, I'm here. I'm happy to have you.
True.
I can put true.
I also say true.
You are correct. So, and the reason is that strings compare in what's called lexicographic order, which is, you can kind of think of it as alphabetical order, though it's a little bit more broad than that. But if I said less than, it'll be false, because mark comes before Maya in the dictionary, so to speak, and even less than or equal is going to be false. Hopefully this makes sense to you. But this is, these are the Boolean comparison operators, and they give us the ability to decide is something equal to something else, which you will see over and over and over again. The challenge for this one is to look at these. These are all in the equals or not equals category, and to try to see if you can figure out which result you will get, true or false, for each of these. If you are in a notebook and you double click on the cell, you get this markdown, what's called markdown syntax. And if you want to make your guess, you can actually edit the cell, put it true there. And you see it shows up over here. Make this a little bigger for you. So you can sort of tag the cell with your answers, and then you can run it, copy. I should make it easy to copy, because the problem with how, I think it might work. I was going to say I thought I was going to copy the dots, but I don't think that will be the case. Anyway, you can tag your answers or just write them down on a piece of paper, then copy these into a code cell and see if you got them right. And if you didn't get them right, those are the ones where I think the real learning will happen. And there's another set here with greater than and greater than or equal to. I didn't do less than and less than or equal to, because it's just the reverse of those. Let me get this out of the way. We're not using that anymore. So those are the comparison operators. Now I want to talk about Boolean operators. And Boolean operators are, instead of comparing two values to decide if something is true or false, Boolean operators are about combining Boolean values. So you have a set of things, each of which is true or false, and you want to combine it in different combinations. And there are three of these. They're called and, or, and not. And as I said earlier, these are like the building blocks of computer science. These are the three things that you will see over and over in every programming language, in every computer. They're called Boolean because they were discovered or invented, depending on your perspective, by a guy named George Boole over 100 years ago. There are three of these, and, or, and not. And I'm just going to walk through them one at a time. So and is true when both parts of the and. It's always written this way, A and B, where I'm using A as a stand-in for anything, any truth statement. A and B is true when both A and B are true. Otherwise, it's false. So if either A or B is false, the whole statement is false. So that's the and function. And an example is, imagine I'm very picky about riding my bike, and I only like to ride my bike when it's sunny and warm. So I have a variable called sunny. This is not legal Python here. I'm just sort of saying this, symbolically. But I have a variable called sunny, and it stores true or false depending on if it's actually sunny out. And then I have a variable warm, which is true if it's warm out and false if it's not warm. And so the Pythonic way of saying my policy, my bike riding policy, somebody just joining us. Welcome, Radha. We're at mcode.fyi/pi2. That's the notebook page we're on. So the Pythonic way.
Mark,
Yeah.
Sir, I think you gave us the long link.
Yes. Thank you.
Oh.
Radha, the link I just gave you doesn't work. What you'll want to do is go into the chat and you'll see a link. Yeah, it's just been copied for you there. So click on that link to get to the notebook. Thanks, Romy, and others for sharing the link. So if I have this variable sunny and warm that are capturing the truth or falsehood of those two conditions, then the Pythonic way of looking at this is my bike riding policy is basically if it's sunny and warm, then I go riding. If not, I don't. And the nice thing about this is it exactly mirrors the semantics of English. So it sounds, when you read, this is actual Python code here. If sunny and warm, call a function called ride bike. It sounds like what it means in English, which is one of the reasons why people say Python is a very readable language. This is called a truth table, and it's capturing what I just said in a more formal way. If you have a variable 1 that's a Boolean value, either true or false, and variable 2, there are 4 possible combinations, right? False, false, true, false, false, true, and true, true. And of those 4, the compound value of variable 1 and variable 2 is only true when both components are true. Hopefully that's clear. Or is also another very common operation you'll see. It's true when either part of the statement are true. Otherwise, it's false. So in a way, it's kind of the inverse of and. And the option, or the way to cast this in a scenario that, for me, I feel like is more of a real world scenario, is that imagine I'm not quite as picky as I was in the previous example, and I'll ride my bike if it's sunny or if it's warm or if it's both sunny and warm. But if both are not true, if the sun's not out and it's cold, then I don't ride my bike. In that case, using the same variables in Python, I would say if sunny or warm, as opposed to if sunny and warm. And that will evaluate to true only if the two constituent parts, only if one or both of the two constituent parts are true. And here's the truth table for the OR operator, and it's hopefully clear. The only case that's false here is when both variables are false. Otherwise, one or the other or both are true, and the compound value is true. The last Boolean operator is not, and not does what it sounds like. It simply inverts a truth value. So if something is true, not that thing is false. And if a variable is false, not that thing is true. It just reverses the value. That's it. You just learned all there is to know about Boolean logic. And I'll just pause for a minute to see if anybody has any questions up to this point. Pretty easy stuff, actually. Okay. Next, I want to look at expressions again. We talked about expressions last time, and I kind of glossed over it. Expressions are combinations of variables and operators. We only had a certain number of operators in the last lesson, and we only had a certain number of data types. So now we can sort of expand what expressions mean with a little bit of a bigger vocabulary. So we can combine constants, variables, and operators in almost any combination to get these expressions. Sometimes we'll see expressions in assignment statements. So in this assignment statement, age equals age plus 1. We're taking whatever the value of age is and we're adding 1 to it and storing it back in age. So we call this incrementing a variable. There's a shorthand way of doing that, which I'll show you in a minute. But this age plus 1 to the right of the equal sign is an expression, a Python expression. You'll also see function calls when we call, you'll also see expressions when we call functions. So this is calling total days times 365 and passing that to print. Let's actually run that. Well, here it is right here. So this is my age, and I'm assuming 365 days per year, so I'm not messing around with leap year here. But if you do days old equals age times days per year, and then I print this F string where I interpolate days old into a nice friendly sentence, it's going to tell me how many days old I am. And I'm 21,900 days old. What I'd like you to do is plug your age into that cell in your own notebook and see if it tells you how many days old you are. I'm betting it's less than my number for everybody. So the expression in this code is right here. It's the age times days per year. Let's see, is there anything? Yeah, I want to say one more thing about this. Let me add another code cell. So I said, let's set age equal to 60 here. Print age. I always like to just do sort of a sanity thing to make sure the world is put together the way I think it is. Now, if I say age equals age plus 1, I'm replacing the contents of age with the current value plus 1. So I'm overwriting age with what it had plus 1. So that should now be 61. You can see it is. I said there was a shorthand way of doing that, and that's like this. Age plus equals 1. That's a special operator, which means add 1 to whatever was in that thing on the left and overwrite it. So if I do age plus equals 1, if you see that anywhere, it's the same as this. Same as saying age equals age plus 1. I'm going one step too big. It should now be 62. And it didn't work because I just wrote print, and it's telling me, yeah, print's a function. What did you want it to do? So I'll finish my thought. And it's 62. Okay. If there are any questions on anything, just unmute your mic and interrupt me. I'm going to just keep charging along. There are multiple types of expressions. We've seen this type, tax equals income times tax rate. That's kind of like the one we just saw up here. There are comparative expressions. So no errors equals error count less than or equal to 0. So here we're checking whether a number is less than or equal to another number, and that will yield a true or false Boolean value. But this comparison right here is an expression. So sometimes we're multiplying or doing math, sometimes we're comparing things. And then there are Boolean expressions, and these use those Boolean operators I just showed you. So in this case, I'm setting a variable called keep going in the case where I have more work to do and there's no errors. And here's a place where the logical and makes perfect sense. If there's more work to do, but I have errors, then I want to stop. If there's no errors, and so the situation, the status is fine, but there's no more work to do, then I also don't want to do anything. Obviously, if I don't have work to do, I don't want to keep going. So the only time I want to keep going is if both conditions are true. There's more to do and there's no problems going on right now. So that's a Boolean expression. And then you'll often see combinations of all of the above, like this, where it says okay to enter equals valid ticket and age greater than min age. So here's a comparative expression, and this and is combining that with another variable in a Boolean expression. And you'll see these things get chained together in ever larger combinations, and there's sort of like no limit to how complex they could get, although they start to get unreadable if you go too far with them. Okay, so how does Python know what order to evaluate a complex expression, like this example, 4 plus 1 plus 5, and that's a mistake. It should be 4 plus 1 times 5. So we talked about this last week, but I wanted to go a little bit deeper on it today. The question is, should I do the 4 plus 1 first? It seems sort of natural because if I start from the left and just move to the right, I would do the 4 plus 1 first. So that would give me 5, and I would multiply by 5, and that would give 25. On the other hand, I can do the rightmost two first. 5 times 1. So if I kind of group those together with the highest priority, I get 5. And then I add 4, and I get a result of 9. So the question is, what is the right answer? Another example here is using these Boolean operators. If I do true or false first, can anybody tell me what true or false would be? Just that subpart of the expression.
True.
That's true. And then when I AND it with false, I get false, because ANDs are only true when both parts are true. So if I do the true or false first, AND it with false, I get false. Now if I do the false and false, this sort of right-hand portion first, false and false is false, because they're both false. And then I OR it with true and I get true. So depending on what order I do this, I'll get false or I'll get true. And so how do we know what Python's going to do? How do we make this predictable and deterministic? And it turns out that Python uses a bunch of rules to make sure this is totally predictable and avoid any of this ambiguity. And the simplified version of the rule looks like this. Parentheses get done first, innermost to outermost, and at things that are at the same level, left to right. Then exponentiation, left to right. Then multiplication, division, and modulus. Remember, modulus is that remainder operator with the percent sign. Then addition, subtraction, then comparisons, then Boolean operators, where there's actually a hierarchy among the Boolean operators. We do not first, and then or. Do you need to know this? No, you don't. I don't ever remember all these rules. And in fact, this is just like a subset. The actual rules, if you click on this link, looks like this table. I do not have time in my life to memorize all this stuff. And so I know a few rules. I know that multiplication and division come before addition and subtraction. I know the Boolean stuff is at the end. But what I do is I use parentheses quite a lot. That way I don't need to remember these rules and I don't get surprised. For example, I could write this expression A and B or C and D, and ands get done before ors, so I know it's going to do those two first, and then at the last step it's going to do the or. But I would write it this way, and if you ever talk to a Python programmer who thinks they're really hot stuff, they might say to you, oh, you don't need those parentheses, and my reaction is, well, maybe I don't, but it makes me feel good about knowing it's going to work. And it also makes my code more readable because I don't rely on other people who use my code having all this stuff memorized. So that's good to know. Here's a challenge for you. You don't have to do it now. In fact, probably good not to do it now, but offline after class, go through these and same sort of exercise. Try to figure out, based on these rules. I just told you not to worry about the rules, and now I'm testing you on the rules, which is a little silly, but I think it's good experience just to think through some of this ambiguity and how it works. And another way of approaching this would be, if you wanted to make it clear to yourself, where would you add parentheses to kind of make it so that you looked at this and it's just obvious how this should be evaluated? So that's an alternate way to do that challenge if you're into it. Next big area is controlling program flow. We'll do about 5 minutes of this and then we'll take a short break. First, I'm going to start with a trivia question. Will the year 2100 be a leap year? And you're probably wondering where that's coming from, and it's actually going to be related to the content, but I'm not going to explain yet why. But I'll just leave you with that question. Anybody want to take a shot at that? I'm not moving on until somebody guesses. Okay. Coyote, looks like you're ready to weigh in. Do I have to call on people, I think. All right, I'll just keep going, but make your own guess. And so up till now, we've looked at really trivial programs that are just a sequence of statements. Do this, do that, do the next thing. But real world problems have what we call conditional logic. And an example of that is, if a year is divisible by 4, we want to do one thing because it's a leap year. And there's a different number of days in the year. If the year is not divisible by 4, we might want to do something else. So we call this conditional or if statements. And it's conditional because the execution path through the code is a function of testing a condition. And the condition can change over time. So it's really a very dynamic thing. An everyday example is, if it's not raining, coming back to my bike again, then I'll ride my bike to work. Otherwise, I'll take public transit. So we do these sort of conditional logic things where we alter our behavior every day, just like the code does. Let's look at some syntax. So the if statement is the standard way to express conditional logic in Python. Every programming language has this concept. And the way it works is you define a condition and a sequence of statements to execute if and only if the condition is true. And that's why we call it an if statement. So once again, Python kind of reads like English to me. You say if some condition, you put a colon at the end that marks the end of the what we call the, I guess it's the pre-clause or the conditional clause. And then after the colon on the next line, we have one or more statements. But the key thing is the statements are indented. How much are they indented by? It's up to you. They just have to be indented. And if you have more than one, they have to be indented the same amount. If the condition is true, the indented statements will be executed. Otherwise, the indented statements will be skipped. And the program picks up right after the if statement ends. So my laptop is getting wonky here. There we go. Kind of went to sleep on me for a minute. Fixing an error. So let me show you an example of that, because I think this is the kind of thing where if you see it, it makes a lot more sense. I'm going to say month equals aug. I'm going to say if month equals aug, which of course it does, colon, okay, it's still summer. Anybody tell me what's not good about this piece of code I just wrote?
I think the quotation mark.
Say again?
The quotation mark, do you have used like one quotation? And it's not acceptable.
Did you say the apostrophe?
Actually, the whole sentence will be between two quotation mark, so that the one single quotation would work.
Thank you. Yes. So I could use double quotes, or I could just put a backslash here, but that should help. So what this will do is print the thing if the condition is true. Print this statement if the condition is true. Let's just verify that, and it does, sure enough. What if I don't indent? Python says you have a conditional without anything to do for it. It says expected an indented block, which is actually quite helpful as error messages go. So I'm going to put the indentation back. And I'm going to put another print here, but I'm going to outdent it. I'm going to say print program done. Let's run it. Now the thing that I want you to notice is it printed both the inner and the outer part. It printed the indented part because the condition was true, and then it was done. After it printed this, we consider the if statement done, and then it printed the program done line. Now what if I say aug becomes July? Or rather month, I changed the value of month to July.
It will just print the program done.
That's exactly right. So when the clause of the if statement only governs the indented stuff, the rest of it is the next line of the program. Now, if I wanted it to do two things as part of that if condition, I can say, okay, it's still summer and more time to vacation. And I'll get its program done. If it's July, it should be printing that for July. I should have used September for the outside of summer part. But anyway, I'm going to put it back to August, and I get all three. Any questions about that? As I said earlier, the indentation can be arbitrary. I could have used four spaces and it would work. What it won't be happy about is if I'm inconsistent within a block of code like this. In fact, even if I'm off by one, I think Python's going to complain. Yeah, unexpected indent. So however you choose to indent, and there's a religious war about whether 2 spaces or 4 spaces is the right way to go. I don't care myself. Sometimes I use one, some the other, but whatever you choose within a given statement, you need to be consistent. Across statements, you can vary. So I could say if month, let me go to parens, if month equals aug. Here I'm going to indent a whole bunch. Wow. I'll get rid of that bracket. Now this is fine. It's just not good style. So this is another case where like the Python is legal because within a given if statement, I was consistent. Within each if statement, I was consistent, but it's just not good practice for other programmers who would be wondering why the heck I did something like that. I have a challenge here, and in Python we use indentation. I just said that to associate the blocks of statements with a condition. So for example, here's a complex if, and what I want you to do is just think through, so I've got this sum condition, and I want you to think through what output you would expect to see before you run it, when the condition is true and then when the condition is false. And a good way to do this is to simply copy that code, add a code block, copy it, and then set some condition up here to hard code it to true or false, and then run your code and see what it does. I won't actually run it now because I want you to do that exercise where you try to think it through first. How are we doing on time? Okay, I think it's time for a break. So let's come back about 1 minute after 10. And I'll stay on if anybody wants to ask a question during the break. We'll pick up in about 2 minutes. Okay, while we were on break, or maybe before, I'm not sure. Looks like before, Subo and Radha guessed correctly that 2100 will not be a leap year, which is surprising because if you divide 2100 by 4, as I'm doing here in this notebook, you get an integer 525, or the float dot zero, which is the same as an integer. So that's a little bit strange, but we'll find out why that's the case. So that's a good guess.
Mark, there's another logic. Like if there's a century, then you have to divide the number with 400 instead of dividing it by 4.
Yes, we will get there. I'm setting you up for the big crescendo, but yes, 2100 is not a leap year because, well, I'll explain why, but I think you already know. We'll come back to that. The if block structure I want to pick up next. As I said earlier, the statement blocks for an if statement are defined by indentation. This idea of using indentation to actually define program structure is everywhere in Python. It's for almost every complex statement. We'll see it in loops. We'll see it in function definitions. We'll see it in class definitions. It's used extensively. It's also quite unique. So there are very few languages that have this, and Python was the first one that I'd ever seen that had this feature. It's actually explicitly defined in other languages. So this is an example of doing the sort of calculation we've been talking about. Take the current year, take the modulo 4. So what's the remainder when dividing it by 4? And if it's 0, then we set leap year equal to true. This is C code. And in C, Java, and C++, we define the block of statements that would be executed for a given condition by using these curly braces. Whereas in Python, the same thing looks like this. I quite like it because I think it's simpler, it's fewer lines of code, and it just looks visually, I can sort of tell what's going on. Indentation in those other languages is a helpful practice and people do it, but it's just for readability. It doesn't change the program's behavior. In Python, it's actually critical to the behavior and the structure of the program. A lot of people have strong opinions about this. It took me a little bit by surprise when I first started using Python, but I got used to it quite quickly, and now I love it. Watch out for mismatching indentation. I showed you an example of that. There's another religious war in tech developer circles about should you use tabs or spaces. I use spaces because it's a little bit more clear and explicit. You can't really see the difference between a tab and a space, but there are a lot of different types of program editors that will expand tabs sometimes depending on their settings. And so sometimes you'll have tabs and they'll get turned into spaces. Whereas if you have spaces, they usually just leave the spaces alone. So my advice would be to use spaces, but the bottom line is you're free to use whichever you choose. Some people like tabs because it's fewer keystrokes, but whatever you use, be consistent with it is my main recommendation. Okay, so our simplest leap year rule is if the current year is divisible by 4, we have a leap year. So we can express that in Python with this bit of code. Leap year equals false. Current year prompts the end user to enter a year. Then we say cur year equals int cur year. That's converting. Input always returns a string. Even if I type in digits, it always assumes the thing coming from the end user is a string. So if I want to turn it into a number, I can say cur year equals int of cur year. This is sort of overriding the string valued cur year with the integer valued cur year. And then I say if cur year %4 equals 0, and I probably don't need the parens, but this is an example of what I said earlier. It just makes it clear to me what's going on. If cur year %4 equals 0, meaning if I divide cur year by 4 and the remainder is 0, that means it's evenly divisible by 4, and that means it's a leap year according to this simple rule we've been talking about. And then I just print out leap year status. So I think I have that code here. So yeah, let's run that, just make sure it works. I'm going to enter 2020. And it says leap year status true. I will enter 2021, and it should say leap year status false. Good. Let's try our test case 2100. As we already know, it's divisible by 4, so it says true, and we also know that's wrong. So we'll get into why that's wrong. One question I want to ask you is, what is this statement doing? Leap year equals false. Anybody wants to venture a guess, jump on the mic. Why do we need that?
Because if it fails the conditional statement, that's how it, like it has to be either or. If that,
right.
Yeah.
That's exactly right. If cur year, if it's divisible by 4, then I'll be setting leap year whether leap year was ever set before or not. But if it doesn't satisfy that condition, and then I go print leap year, it doesn't have a value. So this is sort of the default base case. And we call this initialization. Set your variables to something sane that makes sense. In this case, I want to set it to false, because if I don't come into this if statement and set it to true, I want it to have the opposite value. If I set it to true, it's true no matter what happens here. So I can say 2101, I guess I was 2021 was the one I used before. And it's going to say everything's fine. Actually, it's going to say something really weird. Stir leap year. That's because I pasted something by accident. What I meant to do was true here. Try that again. 2021. And it's true no matter what happens here. So let's go back to false. If I actually comment this out, run it, and say 2020, code is fine because it hits this if statement and sets leap year and everything's happy. But if the if evaluates to false with like 2021 now, it's going to get all the way down to this print, and it's going to say, run that again because I think I was getting the output of an interruption. That was not what I was expecting. Let me see if I can, let me know if anybody sees what I was expecting to get an error here. Oh, I think I know why it is. Because I've set leap year in a previous incarnation of this cell, and this is sort of a quirk of notebooks that you should know about. They're stateful, meaning all across these cells, there are variables I'm setting and clearing and doing things with, and they're remembered by the back end, by what's called the runtime. So if I ran this cell earlier or a cell above it, and it happened to set leap year to true, and leap year is still kind of floating around. So the way to get rid of that is to restart the runtime. That's going to wipe everything out, start everything over from scratch. It takes a few seconds. Okay, it's up. Now if I run this, again, I'm going to enter 2021 because I want it to fail that if statement and hit an error for saying on this print that that variable isn't defined, which is saying here, leap year is not defined. Now, if I uncomment it, 2021, I'll get that's false. Okay. Hopefully that was clear. Interrupt me if it wasn't. That was the if statement. The simplest possible if is just an if and one or more statements indented. The else is when you have something you want to do when the if is not true. So it's sort of like saying otherwise. And it looks like this: if condition colon block of statements, else colon block, another block of statements. If the if is true, it does the first block. Otherwise, it unconditionally does the second block. So else says, if it's not true, just do these. Don't ask any questions. Else blocks are also defined by indentation, just like if blocks. You're going to see this everywhere. And this right here, that wasn't as good, I think. This first example is different from the second example because the statement 3 is not indented. So in the first case, if the if is true, it'll do statement 1. Otherwise, it'll do 2 and 3. In the second example, if the condition is true, it'll do statement 1. Otherwise, it'll do 2. And no matter what, whether it's true or false, it's going to do unconditionally do statement 3. And I have an exercise for you that's kind of around that principle, that when some condition is true or when it's false, I'd like you to predict what the output would be. All right, so now let's revise our leap year program to use else. So current year is input the year, then we convert it to an integer. We take the modulus of 4. If it's 0, we set leap year equal to true. Otherwise, we set it to false. This is very close to what we had before. What it buys us is we don't have to initialize it. And I'm not even sure if I would do it this way. I just kind of forced this example to show you the else clause. But because there's an else clause, if the condition's not true, we're guaranteed we're going to hit one or the other of these. So we're going to come out of this if statement with leap year either set to true or false. And technically, I don't have to initialize leap year because of that. We'll just prove that. We'll say 2020 and get true, hopefully. And we'll say 2021 and get false. So that's the else statement. Should be pretty straightforward. Now we have one more in the if domain called elif. And elif is short for else if. So this is where we have multiple conditions that we want to kind of string along one after another. So like if A, then do X, else if B, then do Y, otherwise else do Z. So a lot of times we have these kind of conditions where we want to check for multiple things in a row. If this is true in this example, it does thing 1. If it's otherwise, it checks. And if condition 2 is true, it does thing 2. Otherwise, it unconditionally does thing 3. Elifs, not surprisingly, are defined exactly the blocks for elifs in the same way as if and else blocks using indentation. It's good to have an if elif for every condition you care about. A common error is to lump things together, errors with cases you care about. And there's an example of this here. Imagine this variable x. It can either be 1 or 2 or something weird that's unexpected. If it's 1, you say if x equal 1, handle it. Elif x equal 2, handle that. Else, it's something other than 1 or 2. I consider that an error. I call a function to deal with that error. That's better coding than this. This next example you can get away with, but it's not really best practice. So this says if x equals 1, handle 1. And there's a temptation here to say, I can just use an else here, because if it's not 1, it's probably 2, right? Maybe, but maybe it's 2 or some other weird value. And so it's better to be explicit with the example, with the earlier example. Here's a challenge. Again, try to figure out which output you'll get when both conditions are true, when both are false, when one is true and the other false, and the reverse of that. Going kind of quickly, but I think this is fairly straightforward material, so I'm hoping it's okay, but stop me if I go too fast. We can have something called nested if statements. This is like an if inside another if, and we call these nested. We can embed if statements anywhere. We can have an if inside the if block, inside the elif block, inside the else block. We can have if else, if elif else inside elifs and ifs, and like it gets stacked arbitrarily deep. And real world logic is often like this. It's hierarchical, it's multifaceted, and it's sometimes very deep. So this is a really nice construct for building arbitrarily complicated logic. Here's another challenge. I think you know the rules for how these work. Let's now improve our leap year rule. I'm going to add another element, which you may or may not have known, is that leap years are leap years if they're divisible by 4, but not divisible by 100. So that is why 2100 is not a leap year. It is divisible by 4, but it's also divisible by 100, and that violates a rule. How can we encode that in Python? Well, we'll go back to the same program we've been seeing. We set leap year equal to false, just initializing our variable. Get the current year, convert it to an integer. And now we're going to say if current year %4 equals 0, meaning if the year is divisible by 4, we pass the first test. But now we want to do a second level of testing. And here's where we chain or nest one if inside another if. So the statement block, the indented piece of this if, is an if. It's an if inside an if. And that's because the first thing we want to do if this if condition is true is to do another test on top of that. We want to say, is it not divisible by 100? The modulus 100, is it not 0? If it's divisible by 4 and not divisible by 100, then it's a leap year. Let's run that. So 2020 is divisible by 4 and it's not divisible by 100, so it should be a leap year. And we get true. Now let's do 21, the one we've been talking about, 2100. It's divisible by 4, but it's also divisible by 100, so it should tell me false. And sure enough, it does. Anybody want to guess what we'd get for 2000, 20 years ago? It's divisible by 4, but it's also divisible by 100, so it shouldn't be.
False.
And it says false, but in fact it is, and we'll see in a minute why. I keep adding levels to this because I think it's fun to know this, but also it's a nice example for how conditional logic works. Now there's a variation to what we just did. Instead of an if inside an if, we could just use pure Boolean logic, and it looks like this. The leap year equals false is the same. Get the input, convert it to an int, all that's just boilerplate now. But instead of the if inside the if, we kind of combine the two calculations with an AND operator. So we say if current year %4 equals 0, and I could technically get rid of these because I know Boolean is the last level. Makes it a little less ugly, but I wouldn't bother you if you wanted those there. But I can say if current year %4 equals 0 and current year %100 is not 0. And I like this formulation because, again, it sounds like English. If the current year is divisible, I read this as if the current year is divisible by 4 and not divisible by 100, then leap year equals true. And I'm not going to run this. Well, I will just because it's nice to not wave my hands. 2020 is true and 2100 should be false. Okay, so that's just another way of doing the same thing. And you can sometimes combine these things in different ways to solve the same problem. And that's where the creativity of programming comes in. So what does the above code print? I already did that. For 2000, it says it's not a leap year, and actually it is. So here's the whole story. A year is a leap year if it's divisible by 4, but not divisible by 100, unless it's also divisible by 400. And 2000 is divisible by 400, so it actually was a leap year. Now, this is a little bit weird, but I want to work our way up to writing a program that will do that. That will do that calculation, and that's one of your homework problems. Okay, we have 10 minutes left. Any questions? I heard somebody say something. Okay. Yeah, in the last 10 minutes, I want to show you a couple of things. Something called importing modules. So importing is how you use someone else's code. And the one example I'm going to give you right here is imagine you wanted to generate a random number between 1 and 100. There's a handy module called random. And what you say is import random. And that essentially tells Python, pull the random module, this collection of functions that someone wrote and shared with the world to do random generator things, pull that into my current program. And then I'm going to use it by referring to the module name, then a dot, and then the function within the module that I want to do something with. So here I'm calling random.randint. Randint is a function that will return a random integer in a range that you specify. And the range is specified by passing arguments, just like we pass arguments to print. We pass arguments to randint to say the range of values we want. So I'm going to do range of 1 to 100. And then I'm going to print what it returned. Well, it returns it and stores it in this variable number, and then I'm going to print number. So if I run that, I get 13, I get 18, 55. You get the picture. If I change this to 1000, frequently I get bigger numbers because I now have a much larger range. If I wanted to, I could say for I in range, I haven't shown you loops yet, but that's what we're going to look at next week. I'm going to say for I in range 1000 colon, and then I'm going to indent these lines. And what this is called a loop. It's going to run these lines 1000 times. If I do this, I'm going to get 1000 numbers, which actually, just to show you what that looks like, I'm going to turn it down to 10. Let's see what the loop does. It generated 10 random numbers. But I want to do something more impressive. So instead of just printing every one, I'm going to sum the numbers. And I showed you that plus equal syntax. I'm going to say sum plus equals number. I'm adding to a kind of accumulating count of the numbers I'm allocating. In order to use this plus equals, sum has to pre-exist. So I'm going to start it by saying sum equals 0 outside the loop. Don't worry if this doesn't make sense because I haven't explained what a loop is yet. And so this is just like a little bit of a taste of what's coming next lesson. I set sum to 0. I go through this range of values. I pick every time through, each 10 times through, I pick a random integer between 1 and 1000, add it to this count. And then at the end, I'm going to print out the average. So that will be sum divided by 10. Now, I don't like the fact that there's a 10 here and a 10 here, because if I want to change one of them, I have to change both places. So I'm going to, of course, use a variable. I'm going to say count equals 10, and I'll put the variable here in place of that number, and I'll put the variable here in place of that number. And now, if I want to change this code, I only have one place to change it, and I'm going to actually change it in a minute. But let me run this. It runs through 10 times, and the average was 427. Reasonably close to halfway between 1 and 1000, right? We'd expect it to be 500. The reason we're so far off is because we're only doing 10 trials. So let's do 10,000 trials, and at the same time, let's see how fast Python runs 10,000. See how fast that? I mean, that was like literally instant. I'm going to do 100,000, just see where we start noticing problems. Still blazingly fast. And you see with that kind of number, we're getting very close to the actual mathematical average. I think if I do 1 million, it'll probably start to show some. Yeah, so it's taken, but even that was like a few seconds. Okay, enough playing with that. That's what importing is all about. And I have one example program I want to show you, which uses if. And I like to try to add a little bit of a fun program each time that uses some of the stuff we are playing with. And so there's something called the Turtle graphic system, which is something that we used years ago to help kids learn how to program. And it's been ported over to Python, and now it works in this Colab environment. All you have to do is run this cell that says pip install Colab Turtle, and you get this functionality. And then I say import random for the random number generator we just saw. And then from Colab Turtle import star. This is a variation on the import statement, and I'll explain that in the future. But for now, just think of this as very close to import random, except for the Turtle graphics thing. And then here I'm going to run this code, and you can see what it does. It draws a star with random colors. I'm showing you both the randint function on the number of colors, and what I'm doing is I'm drawing these lines one at a time, and I'm shifting the angle at the end of each line segment and drawing the next one. And I need to do certain things differently depending on whether I'm on the inner part of a line or the outer part of a line. And so I need to know whether this is like as I'm looping through these numbers, I need to know, am I working on an odd number or an even number? And that's where these two if statements are coming into play. By saying if x% 2 equals 0, that's saying, if I divide x by 2, will the remainder be 0? That's equivalent to saying, is x even? Okay, so every time through this loop, if x is even, I do one thing. If it's odd, I do another thing. Actually, here it's just I do the one thing. I'm changing the color every second arc. So like if you notice, these colors match on the stars points. So every time it's an even number, meaning it's the start of one of these points, I change the color, but I keep it for the odd ones. On the other one where I set the angle that I want to turn, that is different for even and odd, and that's why you see an else clause here. Again, I don't expect you to understand this. We're doing things in this example that I haven't explained yet, but I just wanted to show you a real example of using if and else and import and random and this nice little graphic system in an example. This is another case that I thought was kind of fun. It's only 7 lines of code or something, and it does kind of what we used to call in the US the spirograph. Was a toy we had when we were kids, some of us, where we would run this thing around in a circle, and it does sort of a virtual spirograph. We are 4 minutes away from being done, so I'll just mention there are homework assignments here. Actually, give me until tomorrow morning to freshen these up. I think it's in good shape, but I need to tweak these a little bit. So give me just till tomorrow morning to get these in industrial quality, and I'll send you mail in the morning to let you know that they're ready to attack. Yeah, I think we're done a few minutes early. Does anybody have any questions? Catherine remembers the turtle. Well, maybe we'll do another turtle exercise later in the course. Sounds like no questions. I hope this was helpful. Jordan, stay on the line and we'll talk about your question. And anyone else who wants to ask questions outside the group environment, feel free to stay on the line. I'm going to stop the recording and I will share the recording as soon as I'm able to get it into shape.